This is lecture 19 on urban transportation planning. Today we will continue our discussion on modal split analysis and probably complete our discussion on this topic. Before we proceed further, let us quickly recapitulate what we did in the previous class. You may recall we mainly discussed about calibration of multinomial logit model by maximum likelihood method, taking the data pertaining to the city of Tiruchirappalli as the database for understanding the calibration process. First we discussed about the reason as well as the process of data segmentation for mode choice modeling. We now understand very clearly the reason for segmenting data for mode choice modeling and the procedure of segmenting the data. Then we discussed in detail about the calibration procedure and the identification of variables that will be used for mode choice modeling. In that context, we made a comparison of mode choice in Tiruchirappalli city and in the city of Braunschweig in Germany. We found that the pictures were totally contrasting. For example, we found in Tiruchirappalli city private transport mode usage is just 9%, and the corresponding figure in the case of Braunschweig city is 47% usage of car. So this contrasting picture has to be kept in mind, and I underlined the important point that the developing countries are also tending towards the situation existing in developed countries. This fast changing scenario has to be kept in mind while we plan for transportation system. This is not with respect to only a city in Germany, it is a global phenomenon. If you look at a similar statistic pertaining to the city of Adelaide in Australia, you can see that car usage as driver constitute 57% and car usage as car passenger is 26%. Both together is about 83% of the trips are made using cars. Just compare this with the figures pertaining to Braunschweig city. So it is worse than Braunschweig. Situation is same almost in other parts of the world like USA, Canada and so on. How they are able to make so many trips using cars? Are they very rich? What is the income range in our country? Monthly income range. Shall we say that the minimum average monthly wage, leaving out the extremes, is about 2000 rupees and maximum 60,000 rupees, leaving out the extreme values, small percentages. Now under our condition we find that the monthly maximum is about 30 times the monthly minimum as far as income is concerned. And if you look at this range in most developed countries of Europe as well as USA and Canada, the average figure works out to as follows. The minimum and maximum are not very widely separated. The maximum is about 10 times the minimum, given considering a worst scenario. Maximum is just 10 times the minimum. This implies that there are lower middle class people living in developing countries also. In spite of that, so much of car usage. How it is possible? There are specific reasons. If you compare the price of a medium sized car in India, the price can be equated to about 3 years salary of a middle level worker, let us say supervisor, earning a salary of about 10 to 12,000 rupees per month. Assuming that the price of a medium sized car today is about 3 lakh rupees, it works out to approximately 3 years salary. The equivalent amount is about 3 years salary of a middle level worker in our country. If you do the same comparison for a developed country, the price of a medium sized car works out to be equivalent to approximately just 3 months salary of a middle level worker, right. So, that is how the purchasing power of people living in developed countries is much higher compared to the purchasing power of the people in developing countries. So, you can imagine just even lower middle class people can afford to own a car. It is very cheap compared to their monthly income. And if you do the same calculation in respect of the price of fuel, in our country today, in India today, the price of 1 liter of petrol is equivalent to price of how many cups of coffee? Taking that today's price is roughly 70 rupees per liter, even though it might be slightly more. Now, assuming that the price of 1 cup of coffee in a medium or middle class hotel is about rupees 7, you can say that price of 1 liter of petrol is equivalent to price of 10 cups of coffee. Whereas in most developed countries, price of 1 liter of petrol is equivalent to price of half a cup of coffee, right. The price that you pay for 1 cup of coffee can fetch you 2 liters of petrol if you pay the same money for getting your fuel. You can just imagine the affordability in filling fuel for the cars in developed countries. How do you compare the cost, relative cost of fuel in developed country and developing country? We have a clear comparison. I said in our country price of 1 liter of petrol is equal to price of 10 cups of coffee, whereas there price of 1 liter of petrol is equal to price of half a cup of coffee. That means petrol here is 20 times expensive, higher compared to what is prevailing in developed countries. That is why people are able to make use of car very easily, right. This has to be understood very clearly, and you may wonder whether such a situation is going to prevail in future in our country. It may not, but in spite of the adverse condition for people to buy cars, buy personal motorized vehicles and purchase fuel paying higher price, the vehicle ownership is increasing at an exponential rate in terms of absolute numbers. The reason is, even if 5% of Indians are rich, the total number works out to a very high value. So, that is how we must understand the increase in personal vehicle ownership in our country. The numbers are too many. So, this is the reason why private vehicle or personal vehicle ownership and usage is very high in developed countries. Then With this understanding, let us try to check whether we have really captured the essence of the previous lecture by asking ourselves a set of questions. Recapitulation of lecture 18. The first question is this: what is the purpose of data segmentation in modeling mode choice? The purpose of data segmentation. Purpose of data segmentation. Why should we segment data? Why not just collect the whole of the mode choice information and put the data into a mode choice model? I hope all of you are clear what we really mean by data segmentation, right? Dividing the data set based on certain factors. That is what we mean by data segmentation. Why should we do that? Because the data set has to be homogeneous for your model to be accurate to the extent of replicating the reality. Okay? Unless your data set is homogeneous, you will not be able to develop a good model. So, just to reduce the heterogeneity of database and enhance the homogeneity of your data set, we are doing data segmentation, right. The next question: list the factors that are normally considered as the basis for data segmentation. What are the factors that are used to segment your data? Please recollect a data segmentation flow chart that we saw in the previous class in respect of the Tiruchirappalli city. The first factor is related to trip characteristics. It could be based on trip purpose or trip length, and most of the times we segment data based on trip purpose because that influences mode choice to a significant extent. That is one factor. Then based on, you please recollect the three baskets that we discuss quite frequently, and all these factors must emanate from these baskets. We have already exhausted one basket. We discussed about segregation based on trip purpose. Other basket consists of socio-economic characteristics. So obviously we need to segregate or segment data based on socio-economic characteristics of travelers. And yes, any other basis on which you can? I said that number of available choices for a set of travelers should be same. You cannot combine travelers with different alternatives being available for them to make their trips. If you just have 1000 observations in a sample, all the 1000 individuals must have the same number of alternatives for travel. If some of them have, say, 500 have only 2 alternatives, another 500 3 alternatives, if you put them together and develop a model, your model will not be replicating the reality. The available choice set for the travelers should be same. So you have to segregate data based on the choice set available for the travelers. Clear? So these are the three important factors which are used as guidelines to segment a data for mode choice modeling, isn't it? Then how to account for the possible change in the characteristics of public transit modes in mode choice analysis. We discussed about this point in the previous class, change in the characteristics in terms of frequency of service, for example, change in system characteristics might happen over space, particularly in respect of public transit service. How do we account for this change in mode choice modeling? Again we do, yes please.
Those people who are living in the outer areas, they will prefer public transport and they will prefer their own personalized transport, and those who are living within the CBD, they will preferring the public transport system.
Right, then how do we segment the data then?
We will divide it into choice and captive users.
Yeah.
Based on the vehicle ownership of
not exactly. We have to segment the data based on a residential location of the travelers. When they are living in an area where the frequency of public transit service is very less, then the relative attractiveness of the public transit is going to be less. If they are living in an area where you have a very high frequency of public transit service, it is going to be an attractive alternative. So we have to segment the data based on the residential location of the travelers. Okay, that is how we tackle this particular situation where there is variation of the characteristics of public transit mode over space, right. To emphasize the point of segregating or segmenting data based on trip characteristics, let us look at this information pertaining to Chennai city. This table provides you information on length of trips made for different purposes in Chennai metropolitan area in 2008 as well as in 1995. If you compare the values in the last column and the last but one column, you can see the numbers in the last column are less than the numbers in the other column pertaining to the year 2008. Why? Why the numbers are larger pertaining to the year 2008 compared to the corresponding numbers pertaining to the year 1995 in this particular case?
Over a period of time, the expansion, due to the expansion of the city, the distance between the two places has also increased.
That is right. It is the after effect of the fast expansion of cities over space. Okay. The metropolitan effect is realized. The trip length is bound to increase, right. And interestingly, you can see, you look at the values pertaining to the recent period 2008, the trip lengths are different for different purposes, right. Home based work 7.85, home based education 5.55. Home based education in 1995 was just 3.5, now it is 5.55, a drastic change compared to all other cases, a high percentage of increase. It is partly due to the phenomena of expansion over space, and partly due to the attitude of the people looking for very good schools to put their wards, okay, irrespective of the distance of the school from home. When everybody is trying to do that exercise, this results in increased trip length for the purpose of education. This factor plus the spatial expansion together has resulted in a very high increase as far as educational trips are concerned. Home based others 5.1, work related business 7.2, non home based others 8.05, non home based trips from somewhere to some other place and so on. So this is the average trip length of Chennai city. A similar values you can perceive for most metropolitan cities in our country. For Chennai city, I would say the average for all purposes together, you can assume that to be about 7 kilometers is the average length of one trip made in this city, which is highly intensive. Ideally, as transport system planners, we must plan to reduce the trip length by integrating land use and transport system planning. We must aim for reduction of trip length as well as reduction of even number of trips, so that ultimately the travel intensity gets reduced. Let us look at a similar information based on modes used in Chennai city. Length of trips made by different modes in Chennai metropolitan area, mode wise trip length. Walk in 2008, average trip length is 1.5 kilometers, bicycle 4.68, intermediate public transport like auto rickshaw, taxi, cabs and so on 7.8 kilometers, motorized two-wheeler 10.38, car, van, jeep 14.10, private bus like college buses, software company buses and so on 12 kilometers, and public buses 9.9, train 12.41, right. So, these are average percent trip lengths using different modes. That is how you must understand these numbers. Of course, if you look at the corresponding values for the year 1995, in most cases it is less, in certain cases it is more also. In case of IPT, it is 12.2. Now it has come down to 7.8, partly because of increased personal vehicle ownership and also because of availability of services in large numbers with different fare structure, share auto, independent auto rickshaws and things like that. That is how trip length has come down by IPT, and private buses as well as public buses trip length has come down. Okay. Could be mainly again because of the increased private vehicle ownership and other related factors, maybe increased service of bus to reach out to places from origin to destination. Earlier they might have been taking circuitous route because bus service might not be available, longer shorter route and so on. All these factors might have resulted in a longer trip length earlier, now it has come down. Okay. So, these two tables underline the need for data segmentation for mode choice modeling based on either trip purpose or mode used. So, there is a reason for segmenting data based on trip characteristics. Okay, that is the point to be understood very clearly, right. Now, let us continue from the point where we left in the previous class. This is where we closed in the previous class after identification of the set of variables for mode choice modeling. I would like you to remember the binary values for the dummy variables considered here. Age, the variable will take a value of 1 if the person's age is more than 55 years. Elderly people means 1, for others 0. Sex, 1 for female, 0 for male. Relationship to head of the household, 1 if the person is head of the household and 0 otherwise, right. These are the things to be remembered for subsequent, to appreciate the subsequent discussion. As you would appreciate, we should have considered the factors related to trip characteristics, socio-economic characteristics and transport system characteristics in the mode choice modeling process. Have we taken all these characteristics here in this list? Look at the table and let us check whether we have identified variables from all the 3 baskets. Which is a variable pertaining to the basket of trip characteristics? Trip characteristics. Look at the title of the table. Explanatory variables for mode choice in work trips. So, we have already categorized trips based on trip purpose. Okay. So, we have already picked one aspect from the basket pertaining to trip characteristics. How about the variables pertaining to socio-economic characteristics of travelers? Age, shall we say it pertains to socio-economic characteristics? Social characteristic, isn't it? Age. Sex, relationship to head of household, number of bicycle per worker, right? It is economic characteristic, isn't it? Vehicle ownership, and then number of motorized 2-wheeler per worker. All these 5 variables pertain to socio-economic characteristics of travelers. They reflect the individual characteristics of travelers, not the combined characteristics of household. That is very important, because we deal with disaggregate modeling, right. Each of these variables reflect the characteristics of individuals: age, sex, relationship to head of household, number of bicycles per worker, number of motorized 2-wheelers per worker. All these things pertain to individuals making trips. They may be members of household, but you can associate these variables with individual traveler, right. And what are the variables related to the transport system characteristics? How about travel time? Different modes may provide you different travel times. Obviously, travel time is one of the important characteristics of transport system. Travel cost, different modes imply different cost of travel, isn't it? So, travel time and travel cost are the variables related to transport system characteristics, and the dummy variables are again related to a special aspect of the choice set being different within a socio-economic group. If a person is within a choice set, but unable to use a particular mode, we introduce, to explain that situation, we have introduced the dummy variable. You cannot associate this with any of the 3 groups. We can call this as a special set of variables to take care of this particular situation, right. So, we have stratified the data based on trip purpose, and we have identified 5 variables related to socio-economic characteristics of travelers and 2 variables related to transport system characteristics, right. Next, let us see how each one of these variables will influence choice of different available modes. The grouping, as we have seen earlier, has been done as shown in the column titles of this table. We have grouped the travelers as no vehicle owning group, bicycle owning group, 2-wheeler owning group, again within that with bicycle and without bicycle, and car owning group, right. And let us just fix one variable and see or identify the relevant modes. Age of an individual will influence, right, the probability of choice of these modes. Bicycle, right, in that particular group, if that person is in that group, bicycle choice will be influenced by age, isn't it? And similarly, in the other group again bicycle will be an influencing mode. Then if the person is in the other group, two-wheeler, or in general you can say age will have significant influence on the choice of bicycle and motorized two-wheeler. Okay. If a person is elderly person, we are going to have the value of the dummy variable as 1, isn't it, right? So please remember the binary values for the dummy variables. Then sex of individuals will have influence on these modes, bicycle, again motorized two-wheeler. Relationship to head of the household will have significant influence on the choice of bicycle, two-wheeler and two-wheeler, as we have indicated here for the 3 groups. In the first 2 cases, the effect will be positive or negative. Effect of age and sex in the choice of bicycle or two-wheeler as mode of transportation. Assume that age has got a value of 1. Elderly people, would they prefer to use bicycle and motorcycle? No, it will have a decreasing effect, negative value, isn't it? Sex, for that city, as I said, sex was found to be a very significant factor. Will ladies and girls use bicycle and motorcycle in large numbers? Obviously, there will be a decreasing effect if you put number 1 for sex. If the individual considered is a lady or girl, the relative or the quantum of choice will have a decreasing effect on these modes. Whereas, if the person is head of the household with number 1 for this variable, then choice of bicycle and two-wheeler will have positive effect, right. So that is how we need to understand, have a feel of the variables in your model. Number of bicycles per worker, obviously it will have a positive effect. More the number of bicycles per worker, more will be the choice of that particular mode. Number of motorized two-wheeler per worker will influence two-wheeler choice. Travel time is taken as a generic variable common for all modes, right. The time is more, obviously choice of that particular mode is going to be less. Time will have a decreasing effect on choice of any mode. Cost, generic variable for all modes common. So more the cost, less will be the choice of a particular mode. It is a relative figure, we have to see how it works. Walk dummy, as we discussed earlier, pertinent to a particular group, and bicycle dummy, and then two-wheeler dummy. Okay. These are the set of different variables that we are going to consider for calibration of logit model by maximum likelihood method.
Walk dummy, shouldn't it be for the no vehicle owning group?
No vehicle owning group, what will be the?
Walk dummy. So
could you be louder?
Walk dummy, you have assigned walk for the bicycle owning group.
Yeah.
Shouldn't it be for the no vehicle owning group?
I would say that this dummy fixed for different groups of travelers is based on the available data set also. Let us say there is not much of individuals for whom walk is not available as a mode of transportation. In that particular group, there is no need to introduce walk dummy for that group. what is the purpose of introducing dummy variable? That mode is not available for certain number of people in that particular group. In this particular case, we can say for no vehicle owning group, right, there were negligible or no individual in that particular sample for whom walk was not an alternative. Okay, it was both the alternatives were available for all the travelers in that sample under this particular group. That is understanding. If there is a case, obviously you have to introduce walk dummy for that group also. That is how we need to understand. All these things we introduce based on the data set. Otherwise, if there is no problem, there is no need to introduce these dummy variables. Okay. So that is how I would like you to understand the introduction of dummy variable for different groups. Right. Now let me show you the result of the calibration directly pertaining to these variables. As we discussed earlier, we are developing attribute specific utility functions, not mode specific utility functions. This means that a particular attribute will have only one coefficient value irrespective of the mode in which that attribute is used, or irrespective of the utility function in which that attribute is used to get the value of utility. That is the speciality of attribute specific utility function. You can use the same attribute with the same coefficient across modes if that attribute is relevant for that particular mode, right. So then it is advantageous for us to calibrate the whole of the model and get the coefficients for all the variables and pick the relevant variables and develop your utility function. Okay. So this is the calibrated result of the mode choice model. The coefficients pertaining to the attribute age is given here, and sex values are here. Relationship to head of household has got these coefficients. Number of bicycles per worker has got these values. Travel time, door to door travel time has got these values, and cost of travel will have this thing, and walk dummy will have these coefficients. Please note that this is the result of calibration for only one group of travelers, bicycle owning group alone, right, not for all the groups. I am showing you the calibration result only for one group of travelers, namely bicycle owning group of travelers. And that is why all the variables that we have listed earlier are not finding place here. Some of them are not here, isn't it? For example, number of motorized two-wheelers per worker is not here because that is not relevant in this particular case, because the group considered here is bicycle owning group. Okay. Interestingly, we can find that we have three coefficients for the same variable pertaining to the three different areas: central area, urban area and suburban area. We can also find out whether such a division had been really meaningful or not, based on the assumption that there is going to be a significant effect because of the changes in transit system characteristics. We have divided the data set based on the residential location of the travelers. Let us now check whether such a segregation had been meaningful in this particular case. Look at the value of the coefficient age for central area. It is minus 1.608, urban area minus 0.915, and for suburban area minus 0.896. Let us say the person is aged person, then the value will be 1 of the variable will be 1. So, for an aged person, the decreasing effect on the choice of bicycle, we have already identified bicycle as a relevant mode for this variable age. Decreasing effect on choice of bicycle is minus 1.608 in central area, and in urban area the decreasing effect is relatively less. In suburban area still less. You think of aged people still going for some work, okay, because it is about work trip, people more than 55 years still doing some work, and if they are living in a central area the traffic will be too much, right. Normally aged people may not prefer to use bicycle in such traffic condition. When you go little outside, the traffic condition may not be that bad, right. They might be finding a job around that area, around their home. It may be easier for them to use bicycle as a mode of transport. If they are living in peripheral area, they are not going to commute to the city center every day for work and go. They are elderly people, they will be working around that area. In that case, the decreasing effect on use of bicycle is still less. Is it not reflecting the reality? That is how we need to understand the correctness of division or segmentation of data based on residential location. Otherwise, we would have got same coefficient for all the locations. If the division is irrelevant, there may not be such a variation. So, there should be logical explanation for your coefficients. You must really have a feel of each and every coefficient that you get after the calibration process. Look at the coefficients for sex. Sex is a relevant mode again for use of bicycle in this group. This is bicycle owning group. We have listed earlier bicycle to be a relevant mode for this particular variable sex. For female it is going to be 1. It will have a reducing effect on use of bicycle. You look at the reducing effect, it is very interesting to note here it is minus 1.012 in central area, minus 1.972, it is increasing in the suburban area, and minus 2.978 in peripheral areas, suburban area, and urban area it is minus 1.972. Why it is so? Female working, normally they will prefer workplaces as close to home as possible, as well as they would like to choose a relatively safer mode. In cities and towns, security is also a concern for mobility of girls and ladies. Even today it is true in our country, right. If you take central area, maybe it might be safer and trip lengths are likely to be shorter because you will have several activities close by. They might be working in some place which are very nearby, right. So, the decreasing effect on choice of bicycle is relatively less. When you go to urban area, the trip length may be slightly more and the level of security may be slightly less, and if you go to suburban area, still adverse condition on these two aspects. Trip length may be still more and level of security may be still much less. There may not be any traffic at all on a long stretch of road, one may have to travel alone, all these aspects are there. It is situation and location specific, right. So, unless you understand each of these coefficients based on reality in the field, you will not be successful as a modeler. It is not just simply sitting doing something analytically and getting some numbers. Your numbers must give a feel of the field condition. then only you can be confident about the correctness of your model, both on logical as well as statistical basis. Clear? So, like that it is possible to explain all the coefficients, and look at the sample size for these 3 groups of travelers. There were 1652 observations for this particular group, bicycle owning group living in central area, large number, sample size is very big, and 5711 observation, so many individuals, right, pertaining to urban area, and 4406 observations pertaining to suburban area, right. And look at the t values. T values are given for these coefficients. Maybe if you are interested to check whether these variables are significant, I have given you the t value at 5% level of significance, which is quite normal practice in practical conditions. The value is 1.64. We can find that almost all the variables except relationship to head of household pertaining to central area, right, are statistically significant. All the chosen variables are significant in explaining the variation of the dependent variable, namely probability of choice of a particular mode. And in this case, because of this deficiency, this variable was not eliminated, because in the case of other groups it was significant, right. It was kept in the utility function, so that there is uniformity in the utility function. It is found to be little insignificant, does not matter, it is not going to contribute much, but it is convenient to have the same set of variables for all groups, right. And the utility functions were developed as follows. This is the utility function for the central area. For walk, these are the relevant variables: time, cost, and walk dummy, as far as this particular group of travelers is concerned. Where from we have got these numbers? We have picked out from the table directly. The coefficients are picked directly from the table and written here, right. And utility value for bicycle is written here. Pick the coefficient values from the table and write the name of the variable corresponding to the coefficient, right. V bus, only time and cost were the identified variables, we have put them. And please note that the coefficient value for a particular attribute is same for time irrespective of its location, whether it is V walk or V bicycle or V bus, it is going to be minus 0.330. That is the advantage of attribute specific utility function. Okay. For your information, I would tell you that the cost of travel for walk was taken as 0. Obviously, there is no need to consider any cost, okay. And even for bicycle, even though there may be some cost element involved, if you take into account the maintenance of the vehicle in the long run and divide the cost on daily basis, you may end up with a small amount of money. The cost was taken as 0. You should be realistic, and you can assign values for other variables, okay. That should be taken care of. And similarly for urban area, you can get the set of utility functions as shown here, right. Any question? Are you clear about what we are discussing and how do we get the utility function from the calibration result, just picking the values and formulating the equation. Then suburban area. So we have utility function for all the 3 areas for this particular group for all the 3 alternative modes. This is not the end of the story. We have to finally find out the probability of choice of a particular mode. What is the probability of choice of walk as mode for work trip by a particular group of travelers? That is a question to be answered, right. So that needs to be done using the logic model, isn't it? You can write probability of choice of walk as e power of v walk divided by e power v walk plus e power v bicycle plus e power v bus. We have 3 alternative modes for this group. Now we have the values of v walk, v bicycle and v bus is known to us. Simply substitute the values and get the probability of choice of this particular mode. Similarly, probability of choice of bicycle as mode of travel, e power v bicycle divided by e power v walk plus e power v bicycle plus e power v bus, same denominator because we have the same set. And probability of choice of bus as a mode of travel for work trip, e power v bus divided by the same denominator e power v walk plus e power v bicycle plus e power v bus. Clear? This completes our discussion on mode choice modeling or modal split modeling. To summarize what we did in this class, we started off with recollecting the identification of the set of variables for this particular case study. We found that we have considered the trip characteristics by considering only one trip purpose in this particular case, namely work trip. Then we have chosen 5 variables pertaining to socio-economic characteristics, starting from age, sex, relationship to head of household, number of bicycles per worker and number of motorized 2-wheeler per worker. And the cost and time were the 2 transport system variables considered in this modeling process. In addition, to take care of the variation in the choice set within a group, we introduced dummy variables pertaining to walk, bicycle and 2-wheeler. And we looked at the calibration results pertaining to one group of travelers, namely bicycle owning group of travelers. We checked for the logical aspects or logical correctness of the calibration and found that there is perfect logical correctness in respect of all the variables spread over the 3 distinct regions. The variation of the coefficient values were logical. Then we found, or we tried to understand how to formulate the utility functions from the calibration result, and finally we just discussed about estimation of the probability of choice of a particular mode using the utility functions. So we will stop here. We will continue with another topic, namely trip distribution analysis in the next class.